Hello wonderful person, this is Anton, and today we're going to be talking about new discoveries about our beautiful blue planet. And one of the major discoveries coming from the study you can find in the description is actually in regards to the levels of water on our planet. It seems that back in the days, the planet might have actually looked like this. And here we're talking about Earth being a water world, something that we believe exists in other star systems, but something that we didn't really think was possible here on the planet. But the evidence from the study is actually really strong. But first of all, it's also important to understand that the water levels always change with time, mostly due to climatic conditions and due to various weather effects that do occur on the planet. Here's for example how the levels changed in the last 500 million years or so, with the levels being really high about 100 million years ago, and possibly even being higher about 400 to 450 million years ago. Although some studies obviously have slightly different results. But what all studies agree with is that the levels of water or the levels of oceans on Earth do change with time based on the climatic conditions. One of the better examples here is of course during the ice ages, the levels were about 120 meters below the levels today, mostly because a lot of the water was trapped right here as a very large ice shelf that essentially covered a very large part of the planet, thus lowering the oceans and also allowing certain parts of the planet or certain continents on the planet to be connected. And that's essentially how a lot of animals and even people were able to go from one place to another at least a few thousand years ago. Although about 12,000 years ago the Earth started to warm up and the Ice Age was officially over. But despite these fluctuations, the scientists have always believed that the overall mass of water was more or less consistent. Sometimes it would become ice and thus lower the levels of the oceans, sometimes the ice would melt, like I guess in some sense it's doing right now, and the ocean levels would go up. But the new study kind of argues against that and presents a lot of really strong evidence. The new study actually argues that about 3 to 4 billion years ago, Earth most likely looked like this, with water levels reaching over the peak of Mount Everest, or basically over 8 to 9 kilometers from the surface levels today, while also arguing that this particular condition might have been beneficial for Earth to start its plate tectonics or its geological activity. In other words, the reason we have continents and they move around might have been because of this huge amount of water that was present back in the days. But how can any of this be proven and where is this all coming from? Well, it's actually coming from the idea that we know that there's a lot of water currently trapped inside the planet itself. And a lot of it is trapped inside the Earth's mantle, that thick layer located right below the crust of planet Earth. So approximately several hundred to maybe 1,000 kilometers below our feet. And there's actually a video that goes through a little bit more details in regards to this, but in a nutshell, there are these two minerals that we have inside our planet. This beautiful rock you see right here known as ringwoodite, and this other mineral known as wurtzleite. Both wurtzleite and ringwoodite are basically produced in really high pressures and somewhat higher temperatures inside planet Earth. And overall they're very similar to another mineral known as olivine. And both minerals are known for storing a certain percentage of materials as water. It's actually only about 2% or so, but it's enough overall to accumulate a huge amount of water inside the planet. These minerals represent roughly around 7% of the entire mass of the planet, and even though it's only 2% by mass being water, overall it represents a huge amount of water that's trapped inside planet Earth, enough to create at least a few more oceans on the surface if it were to ever come out to the surface. But in the last few years, as these minerals were studied, the scientists realized that these minerals usually form in specific conditions, basically specific pressure and specific temperature. Here we're talking about several thousand times more pressure than the pressure here on the surface, and also usually temperatures of about 1600 degrees Celsius. However, at higher temperatures, they actually hold much less water. The more temperature there is present, the less water is going to be present inside these minerals, which actually implies that as our planet cools down and as the mantle gets cooler and cooler with time, which is basically what it's been doing for the past few billion years, the water on our planet might actually end up getting trapped inside these minerals and slowly become less and less prominent on the surface of the planet. But this will obviously take a few billion years. Here's the thing though, it also means the opposite. Since the planet was much hotter a few billion years ago, especially after it was just created, And especially during a time about 4 billion years ago, it's a lot more likely that back then the mantle of our planet was much hotter and thus unable to hold so much water inside of it. Meaning that Earth actually started to soak in more water only with time, as it cooled down over a period of a few billion years. At the same time, it's also very likely that initially the planet was kind of dry. There was probably very little water on the surface, and most of the water actually was sort of delivered to the planet through the bombardment of various asteroids about 4.3 billion years ago. At this point, a lot of water was delivered, and this is when the scientists in this paper believe that the levels of water were actually really high. So high, as a matter of fact, that the planet probably looked something like this. Yet it was also extremely warm here, and the mantle itself was very hot, unable to actually soak in any of this water. And surprisingly, there's quite a lot of evidence for this. As a matter of fact, it seems that some of the oldest rocks we've discovered on the planet, such as these zircon crystals from Australia from about 4 billion years ago, definitely formed inside water as well. A lot of them suggest that the water was actually everywhere on the planet, and all of this was formed underwater. Like, for example, these beautiful rocks discovered near Yellowknife in Canada, where it just so happens that I had my first full-time job ever, working not so far from the location where this rock was discovered, although I personally was working at a diamond mine and totally making my ends meet trying to pay off my student loans. Anyway, totally off topic. So these rocks right here were also formed in the oceans. And a lot of really old rocks discovered in Canada and in Australia also indicate that a lot of water was present in their formation. Which once again suggests that at least 4 billion years ago, it seems that water was present everywhere on the planet, thus sort of confirming this hypothesis. At the same time, at least one location in Australia with rocks that are approximately 3.2 billion years old actually suggests that they were formed in conditions where it's similar to clay-like environment, similar to what you find along rivers. And in this case, what this suggests is possibly the formation of first land on the planet, which suggests that the continents were only created a few million years prior to the formation of these specific rocks. And what a lot of this suggests is that on early Earth, the huge amounts of water, liquid water that were present, or basically the fact that Earth was actually a water world, most likely created the conditions for the continental crust to start having more fractures and to become weakened, or to even bend, thus creating the continents that we have today. Or in other words, the fact that Earth used to have so much water on the surface is probably the reason why we currently have this, while planets like Mars and Venus seem to never have had this. And this is actually one of the biggest mysteries. How is it that we seem to have these conditions, these very specific geologic conditions on the planet that don't really exist on other planets? But despite this hypothesis being so good at explaining what may have happened to planet Earth approximately 3 to 4 billion years ago, it actually does create one major problem, the problem for the creation of life on the planet. For example, one of the modern theories suggests that life was probably created either inside the hydrothermal vents or around hydrothermal vents that were formed in depths of different oceans, or possibly near early ponds and early lakes, not so far from dry land that was forming in the beginning. Now, because we know life most likely formed about 3.5 billion years ago, that second theory is already out. If the Earth was a water world, it probably did not have these shallow ponds anywhere. It was just one big ocean. But by being one big ocean, it would also actually make it very difficult for certain nutrients to be concentrated in certain locations such as hydrothermal vents. In other words, the ocean would make all of the nutrients to be kind of diluted and thus prevent the life from forming in certain locations. Or in other words, it just makes it really difficult for scientists to explain how, for example, early life came to be. How is it that early bacteria was able to be created if the oceans were circulating everything and were thus preventing pockets of life from forming? So in other words, it actually does present a few different difficulties. Difficulties in regards to early life formation on the planet, but not difficulties that are going to be impossible to solve. And at the same time, this particular study once again reminds us of how lucky Earth must have gotten in the beginning. So here, had it had more water, or basically if the initial conditions on Earth were even more water-like, it would still be a water world today and thus most likely never have any advanced life on the surface, while by having less water, it would probably eventually lose all of its water and thus become a dry planet similar to Mars. And interestingly, one of the reasons we know so is actually because the study was able to establish the exact parameters for these different minerals for how much water they can store in certain temperatures. And so, for example, by increasing the temperature by about 200 degrees, these minerals will lose about 20 to maybe even 50% of total water present on the inside. And by cooling them down, they will actually start accepting more, thus eventually draining the oceans from the planet in some sense. At least that's what the study implies. Now this will obviously take a few billion years and by then we'll have a lot of other problems to deal with, but that's kind of what the study implies in terms of the longevity of the oceans. And this of course implies that the oceans on our planet are not permanent, they're going to eventually disappear. But what happens to our planet in the future is actually a topic for a completely different video that I'm going to be covering sometime in the future. And so on that note, make sure to subscribe, share this with someone who loves learning about space and sciences, and, well, maybe support this channel on Patreon by joining the channel membership or by buying the Wonderful Person t-shirt you can find in the description. Either way, thank you so much for watching, I hope you enjoyed